Good morning. Thank you to all those who have joined online. We will be starting in about 1 minute's time. Thank you for bearing with us.
It's gonna mess my hair up, Katie, this headset. Where's your hairband gone? Where's the mouse gone? Where's it gone?
Sorry, we're just trying to look for the mouse. It's disappeared.
Right. Good morning, everyone, and good afternoon and good evening to those of you listening to us from a little further east. Sorry about that brief technical hitch. I'm very well known for my IT skills. That didn't go too well, but we're done now. So, welcome to the March 2022 ABL market briefing, live from the old Lloyd's Library here in London. And welcome to all of you online. So today we're going to be talking about using digital tools in marine casualty investigations. A few bit of housekeeping first, of course. This briefing is accredited by the Chartered Insurance Institute, and delegates coming up to 1 CPD hour for their participation. And we'll therefore keep a record of those of you logging in online as well as those of you in the room today. So we've got a record of that, and if you need a certificate or a record of your attendance, please do contact us and we can give that to you. So today I'm delighted to introduce our panel. Unfortunately, the chap you see in front of you there on the screen can't make it. So we're meant to be welcoming Chris Cox on our panel today. Chris recently moved from our Singapore office to our London office. So we've welcomed him to London by giving him COVID. So unfortunately he can't make it. But we're delighted that Chris works in a team with several of our colleagues, and he shared his experience and slides with us today. And his colleague Paul Martin, who's the Maritime Director here in London, will be presenting on his behalf. So a warm welcome to Paul, and thanks for stepping in at the last minute. And best regards to Chris, and hopefully he can recover soon. So just a few words on Chris in his absence. He recently joined us from Singapore, where he was heading up our work in digital tools in marine casualty investigations. particularly with services relating to our expertise in MADAS, which is the Maritime Accident Data Analysis Suite, which is a suite of software programs that we use to recreate marine casualties. The presentation today will touch upon all of that, and Chris is a maritime electronic data analyst, data, whichever side of the pond you're from, and a software specialist. And in addition to his work in marine casualties, he also works on the development of ABL's digital services and our tools that we use to help deliver value to our clients. We're also very pleased to welcome back Charlotte Dodge, who is one of our naval architects, and she's here with us in London, works in our London office, and she's also worked as part of the Marine Warranty Survey team in our Stavanger office in Norway, as well as working with naval architects at ABL across the group and one of our group companies, Longitude. Charlotte has been presenting this month. She'll be presenting the marine casualty case reports after Paul's done with the technical part of our presentation. Usual caveats apply, Chatham House rules apply. The information contained in these presentations and any opinions or comments expressed are those of the presenters and not necessarily those of ABL as a company. At the end of today's briefing, we'll be asking you to kindly complete a very short feedback form. This helps us with our continued CPD accreditation, so please do so if you can. It's mainly multiple choice, yes or no questions, but it's really important to us. So please, if you've got the time, please do so. It only takes a few minutes to do, so we would really appreciate it. QR codes can be found on the desk outside if you're here today, where you register with Katie. So you can just scan that on your phone, or you can take the form with you. And if you're watching online, there's a link to the online survey in the video description underneath the screen here, or you can scan it now on this slide we've got up at the moment. And we'll display this QR code again at the end. Before I pass over to Paul to present our technical discussion, we'll just have a quick look at today's learning objectives. What we hope you'll get out of this is you'll understand what data is out there. We'll try to discover what software tools are available to analyze that data, and we'll learn how these tools can help with marine casualty investigations. Just a very brief word about the Neptune Declaration. This is something that's very close to our hearts here at ABL. We would ask you to give a few moments thought to seafaring men and women at sea today, often working for much longer stretches of time than they were before COVID, and as COVID continues. The ABL Group is a signatory to the Neptune Declaration on Seafarer Wellbeing and Crew Change. And as I said, this topic is very close to our heart. Many of our team are ex-seafarers, as am I, as is Paul, who you hear from in a bit. So, you know, it's something that we would really encourage you to look into. And if yourselves are interested in becoming a signatory, or companies, you know, please look into it. And you know, we think it's something that's really important in the current day and age. So that's all for me, and I'm going to hand over to Paul now for the technical part of our discussion.
All right, thank you, Mark. So as Mark said, unfortunately, Chris has got COVID, so I've been parachuted in at the last minute. So I apologise if some of what I say doesn't quite match what you see on the screen there. But today I'm going to give you a prediction. And unfortunately, the prediction isn't for the lottery ticket numbers that are going to win on Saturday, but it actually relates to the person that should have been presenting, that is Chris. So Chris, as has been briefly mentioned, is a software engineer who joined us from Singapore and runs our electronic capability in the office. So keep in mind the skill sets that Chris has as a software engineer, and I'll give you the prediction at the end of the presentation. So today we're going to talk about electronic data, what's out there and how it's used. And there's a plethora of data out there these days which we can use to help in accident investigations. And there's also several sets of software that can be used to analyze the data. And then once you've analyzed the data, a mariner can use that information to come up with an assessment of what happened, why it happened, and how it could be prevented in the future. So let's have a look at what kind of data we've got out there. So the first one is automatic identification system data, AIS. You may have heard of that term. So what is AIS? AIS is a VHF transmission from one ship to another, and typically the range is about 25 to 30 miles, and it was designed just for ships to be able to identify each other. Out of that has spawned a cottage industry where receiving stations ashore captured the information and started selling it on. And then latterly, they worked out that satellites in space could also see this information being transmitted, and they were grabbing it. So now you sometimes see satellite data for sale as well. And that's all it is. It's the same transmission, just grabbed by a different station. Okay, voyage data recorder, that's the equivalent of an aircraft's black box. The black box is the thing that when a plane crashes, survives the crash, always intact. Makes you wonder why they don't build a whole plane out of that stuff. But anyway, so the VDR is the equivalent of a plane's black box. And formerly, the VDR on a ship would just be recorded in one place. There would be one hard disk recording. Later versions, more modern systems have 3 places. So they'll have one hard disk on the bridge somewhere. They'll have one on top of the bridge on the Monkey Island. That's where they keep the monkeys. And they'll also have a float-free device, which is if the ship sinks, there's a hydrostatic release and it pops up to the surface. And I don't know much about aviation black boxes, but I kind of wonder if there's not the capability to put a float-free device in an aircraft. And you know, if we had that, maybe we'd have found the Malaysian Airlines flight 370 by now. Although apparently they've got some new information on where they think it is. So watch this space. And then finally, VTS data, vessel traffic systems, they'll be set up in port approaches and they capture their own data, radar, transmissions, radar pictures, audio, traffic, AIS, and sometimes, but not always, you can buy this stuff from the VTS authorities. So for example, in Singapore, they're more than happy to flog it to you for $1. In Malaysia, absolutely no way you're going to get hold of it. So once we've got all this data, then we go through the process of what happened, why did it happen, and how could it have been prevented. So this is not a sales pitch for this software. Happens to be something that we use. It's a product by a company called MSG in Holland, and the tool is called Prospector and Plotter. And Prospector is a database of AIS information. So remember I mentioned that cottage industry of people grabbing the data. MSG are one of those people. They've formed a whole business out of grabbing data and selling it. Okay, and then Plotter is the way that you can utilize that data that they've captured. So here's an example of how the data can be filtered. So rather than searching over a wide area, because data normally costs by the megabyte, so to keep the cost down, you zoom in on an area and that keeps your cost down. Okay, so that's how we filter what we want to keep the cost down. And then it spits out an Excel table like this, and to that table you can add things like weather data, and then that can give you a sort of 3D picture like that. So there's a picture of the ship's AIS data, which is the orange data, that's its route, and then on top of that you can see the blue graphical representation of the wind strength on passage. So that's a really nice way to sort of visualize what weather a ship was experiencing on passage. Other things we can do with it, we can take multiple tracks and analyze where the ships were going in a berth. So for example, when a loss of use claim lands on the claims handler's desk for a couple of million and say, there you go, that's how much you need to pay us, we can actually go back and do an independent verification on it and see how much traffic was going to that berth and whether the claim is reasonable or not. And the data can give you a quick replay of what the ships are doing. Let me see if that's playing. It is playing. Okay, so that's Spurn Point on the Humber. I used to be a pilot up there in my former life, and been up and down this bit of river many times. So you can get a very quick overview of what the ships are doing from the data. That's from AIS data. So VDR data. VDR, this is the black box, captures the data that's on a ship. So everything that's on the vessel's bridge, their radars, their gyros, their speed logs, all that kind of information is captured onto this hard disk. And as I've mentioned, on modern systems now, that's stored in 3 places: on the bridge, on Monkey Island with the monkeys, and the float-free device. Audio, we'll look at that in a bit more detail a bit later. That can be quite troublesome, especially when the master and the pilot are on the bridge wing and they're in the final part of the passage where they're berthing the ship alongside. Quite often it's windy, and you can get a lot of background noise, which makes it difficult to hear what people are saying. Even inside the bridge, when you've got bells and whistles and things going, it can be difficult to hear what people are saying. So, I mean, when I was at sea, one of the captains I sailed with, I remember clearly when he was doing the master pilot handover, he used to wheel him underneath one of the speakers so that it was all captured. And, you know, that's a nice little thing to do, a nice trick. Now, the problems with VDR, there are several. Now, the older systems tend to be pretty unreliable, and working on some pretty archaic software like Windows ME, for example, and those systems still exist. And in my experience of attending casualties, when these older systems were installed, I would estimate 50% of them are corrupted. The data's not there, it's not recorded for whatever reason. The modern systems are better, but there's still a lot of cases where you go out to the ship and the VDR data is not available. There's no real standard, so between manufacturers they all have their own different ways of recording it, they all have their own different software, and it's a bit of a nightmare, to be honest. And so if you are a casualty investigator and that's your business, you need to have all this different software from the different manufacturers, and there's about 20 different manufacturers out there. But the VDR is primarily just designed to do a replay. It's not a tool for doing an analysis, so it's not particularly intelligent in that respect. So again, not a sales pitch here. MADAS is a piece of software openly available on the market, which is pretty much the gold standard for accident investigation software. So this software uniquely brings together different sources of information. So, for example, VDR data can be synced with external audio data, can be synced with CCTV, it can be synced with all sorts of different data. So the MADAS software is pretty much the gold standard, developed by a company called Avenka, at the behest of the UK's Maritime Admiralty Investigation Board and the American NTSB, and that's what the MAB use to this day. What kind of stuff does MADAS take? So I mentioned it briefly there. So serial data, which is nothing to do with cornflakes, it's AIS, GPS, that kind of stuff. Image data, so radar pictures, ECDIS. ECDIS is the electronic display, so it's an electronic chart, ECDIS. Photographs, audio data we talked about briefly. Video data, sometimes terminals have video cameras on their berths, so when the ship comes in they can monitor what's happening. So all of this can be combined by the MADAS software into one place, which makes it really useful to bring all that information together. So let's have a look at kind of how we would build it up. We could bring in a transcript of audio, and then we can add gauges, and you can customize the gauges. So on the right, we've got revolutions of the main engine, depth of the seabed underneath from the ship's transducers, and on the left you've got the heading and course over the ground and things like that. So you build the picture up and you can customize it how you want it. That's the transcript, custom gauges, and there's actually the ship which is being driven by AIS data. Nice thing about MADAS is that you can take radar pictures and overlay them onto a chart, as you can see there. So if you were looking at a VDR playback, all you would see would be the radar picture and nothing else. And just for information, those radar pictures are not continuous. It's a snapshot in time every 15 seconds. So on the bridge, whilst it's sweeping all the time, it's a continuous picture. When it's recorded on the VDR to cut down on the amount of data that's saved, it's actually just a screenshot in time, and that screenshot happens once every 15 seconds. And that's the same for the electronic chart system. But as you can see there, you can overlay that radar picture onto an electronic chart, and that's really useful for giving you context about what's going on around those ships. And the nice thing about the radar picture is that whereas an electronic chart, the ECDIS will show you AIS targets, not all targets have, or not all vessels have AIS. I'm talking targets because it goes back to my days in the Navy. The submariners thought there was only two types of vessels. There was submarines and targets. So that's where I've got that from. So anyway, the targets are all shown on a radar normally, and the ECDIS, the electronic chart, doesn't show vessels which don't have an AIS transmission. So for example, fishing vessels might not have it, pleasure craft might not have it, or there may even be a commercial vessel out there that's unit is faulty or has been switched off, thinking back to MH370 now. So it's a really nice feature with the radar to overlay onto a chart to give you context. And you can customize it how you want. You can put whatever graphs on there. So the process of analysis using MADAS, we'll talk a little bit about that now. So this technology has been around for years, and different bits of technology have been coming in over time, and there's more and more of it. Now, in the old days, before AIS in particular, in the good old days, I dare to say, we used to do things called a speed and angle of blow, speed and angle of blow, and this was nothing more than a educated guess. So the surveyor would go out, he'd look at scratch marks on the hull where the hole was, and he'd sort of get his ruler out and he'd sort of make that's about 20 degrees. That's how he'd get the angle. And then the speed would be done using something called Minersky's rules, which is a calculation, and that would be measuring the depth of the impact, and from that, using Minersky's rules, you'd get an estimation of the speed of the vessel when it impacted it. But it's nothing more than an educated guess. That's not done anymore. We have AIS, and that really, has been a leap forward. And MADAS makes the whole thing a lot simpler. It allows us to, as I say, integrate all the data and to ask the questions, of what happened. Particularly when lawyers are investigating cases, they pose questions sometimes, well, what if we did this, or what if we did that? And MADAS can do that for you, and that can be overlaid on the actual track for comparison. So the data that comes out of AIS, which is taken by MADAS and displayed visually, looks something like that in its raw form. Now that's actually not completely unusable. For example, in the middle, you can see at the top, there's one that says HDG, that's heading, that's the ship's heading. So going from top to bottom in time, you can see that this ship is creeping to starboard. So in a collision case, that can be very important, because collisions happen when vessels don't comply with the rules. And one of the rules is that if you're a stand-on vessel, you need to maintain your course and speed. So if you saw that, and you saw that the thing was creeping, that's not good for that vessel. So these can be useful in their raw form, but it's a lot easier to understand sometimes when it's presented pictorially. So here's an example of how that raw data that you just saw can be shown pictorially. Now this is actually old technology in a way. This is a program called AutoCAD, and they've taken each position and they've plotted it manually. So that took quite a long time to do. So although it looks quite modern and high tech, it's actually quite old tech. But MADAS can do that in a fraction of the time. Same things for engine data. So engine movements, for example, you can capture that on the audio on the bridge or the engine data printout. But sometimes, or more commonly now, the engine data is actually recorded on the VDR, and that can be extracted from the system using MADAS and presented pictorially with those gauges that we looked at earlier. So radar we talked about, captured every 15 seconds, and the same for the ECDIS electronic chart screen. So that's the bottom right one there, also captured every 15 seconds. So in MADAS, you could take the electronic picture and put that in the corner and have that playing, whilst you've got the radar picture overlaid onto an electronic chart. So just to show you an example of a very simple case here, two ships going up a river, color coded. So Professor Plum, rather unsurprisingly, in a plum color on the right, and the ship, the big one, is the Professor Plum, also plum colored. And on the left, you've got Colonel Mustard, a sort of mustardy color, and the ship on the left is also mustardy colored. So the point, I'm being a bit simplistic, but the point I'm making is you can visualize things very easily, and it's easier to get your head around what's going on using something like MADAS rather than just having that table of data. I'll move forward because this video runs for a bit too long, actually. The gauges there, we can again, we can adjust the display, what kind of gauges we're showing, and annotate it. As you can see, annotations popping up there, and that can be useful when giving a report to claims handlers or lawyers, or even to judges and arbitrators. And this is just more of the same, so I'll skip past that one. Okay, now here's an example. Remember I talked about audio earlier and how you can integrate that with TV and CCTV and things like that. And that's what we have here. We have an integration of AIS, CCTV, and audio. I'm not sure if you'll hear the audio when we play it. Just so that you know, you can see a white ship in the bottom left-hand corner. That's because this has all been overlaid onto a Google Earth picture, and there just happened to be a ship on the berth when the satellite went over and took the picture. So there isn't two ships there. That's just a Google Earth picture. The ship in question is the orange one, which is moving. Can you hear the audio or not? Can you hear the audio? Okay. So so the audio has been taken from the bridge VDR. The CCTV picture has been taken from the terminal, and the AIS has been captured from a third party, and that's the orange vessel. And I think that's a nice representation of how we bring it all together. And then if we had a particularly nasty case and high value, and it went to court, for example, sometimes it can justify doing a 3D model. And here's an example of 3D modeling using software from Rembrandt. There's also another one called Rhino, but this is Rembrandt. But it is quite pricey to produce these kind of simulations, so only really get them done when there's a big claim and it's going all the way to court. I wouldn't like to be on that tug on the inside there, and it's pretty realistic. I mean, I was a pilot at Felixstowe driving big container ships, and that view that we just had of the containers and you can't see anything at the bow, that's pretty much what it looks like. Okay, we talked about audio earlier. So there's several bits of software for cleaning up the audio. So as I mentioned, the wind noise can really degrade the quality of what you're hearing. This software, there's a couple, one called Audacity, or the rather catchily named Zolop RX Elements, really catchy name. That's that one there. So basically how that works is they will take a period in time when no one's speaking, and they will take that as the background standard, the background level. Once they've logged that background level, when you get to a bit where someone's speaking, they then digitally remove the background level. So it just gives you the voice, hopefully, cleans it up. Chris could explain it better to you than me, but that's essentially how it works. Okay, so in summary, there's a lot of data out there and it's growing in quantity all the time. And without appropriate software, it can be difficult to handle that data, and it can be difficult to visualize it. So there's stuff out there such as MSG Plotter and MADAS, which helps you to analyze it. And it's important for us as a company to keep abreast of the developments, which brings me back to the beginning of the presentation and my prediction. Now, if you remember, I told you that Chris was a software engineer, and we are now moving towards autonomous vessels. So probably in the not too distant future, perhaps not in my lifetime, but not too distant, there'll be a case where a couple of autonomous ships bash into each other. So my prediction is that casualty investigations in the future will probably be done by someone like Chris and not a mariner, because what he'll be looking at is computer algorithms and seeing if what one ship was told to do was correct or not. So that brings me to the end of the presentation. Thank you very much.
Good morning, everyone, and thank you very much for that, Paul. So let's move on to look at some of our cases in a bit more detail. So first of all, what are the ABL case reports? The purpose of this section of the briefing is simply to keep you updated on some of the recent higher cost incidents that ABL have been involved in, and in doing so, show you the sorts of incidents and casualties that can happen in shipping and marine operations. These feature largely, but not exclusively, hull and machinery casualties with estimated costs of repair in excess of $250,000, usually excluding salvage costs. They cover only a subset of the total ABL group caseload, typically in the order of 10%. Now, this is an important subset which represents about 25% of the hull and machinery cases by number, and around 65 to 75% of the hull and machinery cases we survey by cost. The estimated costs are often preliminary and subject to further inspections and/or investigations. In presenting these case reports for the last month, it's not about attributing blame. There won't be specifics of cause, as many of the cases are still fresh, so it wouldn't be appropriate to do so. And in many cases, the cause is still under investigation. A copy of this presentation or a previous one is available on request. So as usual, let's start off with some statistics. So an overview of February 2022, the proportions of cases by number. So starting on the left of the bar chart, we can see that the majority of the cases we were instructed on in February were engine room machinery cases. This was followed by a few collision-elision cases and also others. There were also cases of grounding, heavy weather and propeller rudder damage cases. You can see from the 2021 information, which gives an overview of the cases we surveyed last year. And you can see that so far February is following a similar trend, but has a lower proportion of engine and machinery cases and a slightly higher proportion of collision-elisions. So in terms of costs for February, we can see that the engine and machinery cases dominated the figures for the month, with a quite significant portion also from other cases. The remainder of the costs were made up of relatively smaller proportions of groundings and some of the other categories. The average cost for the month is just under 1.5 million, which is slightly higher than last month's average total of just over 1.2 million. The typical annual background expected figure is about 1 million per high cost casualty when extremes of over 50 million are excluded. So in terms of the overview of 2022 to date, this shows that the engine and machinery cases have also been the most common cases we work on. You can see in this graph that there also continue to be healthy instructions on a variety of work with groundings, fire and explosion, collision-elisions, and other cases, adding relatively more to the total, and currently following a similar trend to 2021. And then in terms of the overview proportions by cost, this shows the total cost for the year so far and shows that the engine and machinery cases still make up the greatest proportion of the costs encountered so far, with collision-elisions also making up a significant proportion. The overall average cost for the year for our high cost cases currently sits at just under 1.4 million, but as it's only February, we're sure this will change over the coming months. Okay, so now we'll move on to look at some of our cases in a bit more detail. First up for this month, we look at the matter involving a roll-on, roll-off cargo and passenger vessel, which is over 40 years of age and approximately 15,000 deadweight tons, built in Canada and classed with DMV. Whilst undergoing a scheduled dry docking for a special survey, bottom survey and propeller shaft survey, a fracture was noted on the port side clutch carrier input shaft, which needed removing for further dismantling and inspection. The starboard side input shaft was also dismantled for inspection and similar damage was found. In this picture, we can see the port clutch carrier being removed from the input shaft. Reported and found damages to the port and starboard input shaft flanges were fractures radially from the keyway fillet and through numerous drilled and tapped bolt holes. On the port shaft, one key was found with two large pieces of material fully detached, and on the opposite key, a fracture was evident which appeared to have come from the key fillet and continued radially around the shaft end and longitudinally along the keyway, but with material still attached to the shaft. Numerous bolts had also sheared. Other damages noted included input shaft pinion gear wheel bore and the clutch gear wheel bore fretted. The gearbox white metal bearings were worn and partially wiped on horns, and the roller bearing inner race sleeve was fractured. In terms of the nature and estimated time of repairs, both input shafts require dismantling and removal. As replacement shafts are not available, new shafts need to be manufactured through reverse engineering. Repair proposals are under discussion for the gear wheel bores, with the option to polish the bores to remove the fretting and make the shaft journal in way of the gear very slightly oversized to compensate. White metal bearings, which number 6 pieces, will need to be remetalled with ultrasonic adhesion testing of the new white metal to the bearing housing. A machine is required, finishing the sizing, reinstallation of the gearbox, and final clearances and fitting. It's difficult to estimate the time for repairs, whilst the proposals, including costing and lead times, are still under review. But based on past estimates, we would say approximately 12 to 14 weeks, allowing 4 to 8 weeks for fabrication and delivery of steel ingot, machining time at a further 4 weeks for both shafts, and then further time to rebuild the shafts with the clutch carriers, and also shipping, reinstallation on the vessel, and then commissioning and a sea trial. The approximate value of this repair is $1.4 million, and no allegation of cause has been submitted. So moving on to the next case, this is a bulk carrier vessel of just over 17,000 deadweight tons, anchored at the starboard side with 4 shackles in the water, but then it started dragging the anchor under the effect of wind and sea, reported to be 30 knots and 4 to 5 meters swell respectively. Upon noticing this, the anchor was picked up and a further attempt to drop the anchor, again with 5 shackles, was made at a later time. However, the anchor was noticed to drag again. Whilst looking for a better holding ground, the vessel manoeuvred into the vicinity of another anchored bulk carrier. An order was given to set the engine to dead slow ahead, then half, and then full ahead in order to keep clear of the other vessel. However, the bulk carrier continued drifting and collided with the bow of the other anchored carrier. While the vessel was proceeding with engine ahead, several contacts were made between the vessel's hull. The other vessel's anchor chain then rested between the carrier's rudder and propeller, during which time several contacts between the steel structures was inevitable. Eventually, the other vessel paid out more cable lengths, freeing the bulk carrier from the other's anchor chain. In terms of damage sustained to the bulk carrier, there is indentation of several plates and frames on the starboard side shell from wing tank number 4 to the stern transom. The side shell holding way of emergency generator room sustained damage. The free fall davit was bent, and the lifeboat pad eye fiberglass fitting has also been damaged. Several damages were also sustained to container stands and a bunker station on the starboard side. This picture here shows some of the extent of the damage sustained, namely to the emergency generator room. In terms of the nature and estimated times of repairs, repairs fall into 2 categories here. The first tranche of repairs is to render the vessel seaworthy and safe for her crew, whilst the second tranche are repairs that should be performed at a shipyard. Broadly speaking, the repairs will cover steelwork repair and replacement. To repair the lifeboat, emergency generator room hull, and main fire line, the difficulty here lies in that the vessel cannot be accommodated alongside a shipyard, but the equipment will need to be transported at the berth location. The remaining repair works might require dry docking, subject to underwater survey, and it should be noted that time to obtain an available dry docking slot can be considerable. The time for steelworks we estimate to be in the range of 20 days, and the repairs have not yet commenced. We estimate the cost of the repairs to be in the region of $300,000, subject to adjustments once the full extent of the damage is known and quotations are received. As already mentioned, there are a number of repairs which need to be made on site where the vessel is located to the satisfaction of class and the harbour master before it's deemed seaworthy again. So next up, we have this oil tanker of 27,000 deadweight tons, which was grounded during heavy weather off the coast of Mauritius. The vessel departed port due to its closing at the announcement of a cyclone warning Class 2 approaching the island. The vessel went to the outer anchorage but could not maintain position. As a result, the vessel steamed towards the southern part of the island. With engines full ahead, the vessel was reportedly not making headway, and with worsening weather under the tropical cyclone, the vessel could not control her heading and started drifting in a southwesterly direction. A tug was sent to assist the vessel under an LOF basis, but for reasons unknown as yet, the tug did not reach the vessel in time, and the vessel later grounded on a volcanic rock coastline. So in terms of the damage sustained, it's noted that the bottom plating is set up and breached in way of the double bottom ballast tanks, as well as the engine room space and the forepeak tank. The rudder has also been damaged from the impact. The engine room is flooded up to the second level with all machinery submerged. The accommodation panels, fittings and furnishings are also variously impacted from water and damage as a result of the heavy pounding and rolling. So in terms of the nature of repairs, these initially fell into 2 scopes, temporary and permanent. So the temporary repairs included sealing of breaches in the hull plating and flooded spaces to be clear of water, with the objective of refloating the hull. In order to carry out the temporary repairs, all the pollutants are required to be removed from the vessel in compliance with the local authorities. Then once the vessel is refloated, it can be dry docked at the port approximately 100 nautical miles from the location of the grounding to undergo the permanent repairs, which will include but not limited to all the damaged steel to be cropped and renewed, all electrical and mechanical machinery and equipment to be inspected, cleaned, tested and repaired or renewed as found necessary, and also the accommodation panelling of furnishings and fittings will need to be renewed as required. So it was anticipated that repairs could take from 4 to 5 months to complete, subject to the damage that was sustained, and it was estimated that the repair costs would be in the region of $3.8 million. However, subsequent large wave action against the hull resulted in the port side shell plating failing in the way of the water ballast and cargo oil tanks at number 2 and 3. And due to the hull plating failing and the weather conditions experienced on site, the vessel is no longer able to be salvaged and repaired. And then finally, last up for this month, we have a fishing vessel of a deadweight of just over 3,000 tons, built in Canada and over 10 years old, which recently grounded, touching the bottom at Hydro Shoal in Canada. So in terms of the damage sustained to the vessel, the following has been noted. There was soft contact was made with the shell plating set up 20 to 50 millimeters from frame 6 to frame 106, almost directly in line with the center line, over a width of between 600 to 1200 millimeters. There are relatively fresh longitudinal scratches to the paint, and underlying steel were also noted in line with the damage, and the internals were found to be set up and tripped aft. As cropping is being carried out step by step, the detailed full extent of the damage has not yet been confirmed. The vessel has been dry docked to effect repairs, and these are anticipated to take around 44 days. So these include the fuel tanks, fuel oil overflow, sludge tank, waste oil drain tank, and centrifugal oil tank to all be cleaned and gas freed for hot work. The damaged steel is to be cropped and renewed, and the section that will be cropped is 400 mm high and 600 to 1200 millimeters wide, in order to line up with either the shell plate weld seams or weld heat affected zones from shell plate longitudinals. Due to all the damage being on the center line in way of the primary docking blocks, work is having to be carried out in a step-by-step sequence with removal and replacement of the docking blocks. The owners have a naval architect on site to supervise the block loading, repair sequence, and steel repairs. Due to the extent and length of repairs, as well as the vessel's long shaft line, there is concern that the repairs may cause abnormal hull deformation. Therefore, in order to monitor this, there are daily laser hull alignment checks being carried out. The vessel is also carrying out its routine scheduled 5-year dry docking at the same time. Estimated costs for this are at $785,000. So that brings us to the end of the case reports, and I'll hand back to Mark.
Thank you, Charlotte. Thanks for that. It's always good to see, in our game, it's good to see that things are still going bump in the night. So that's always good for us guys. Maybe not so much for you guys, but so if we've got any questions for Paul on his part of the talk, we won't really take questions on the case reports because they're all still ongoing investigations. But have we got any questions? Anything online? No. Fantastic. You might get your hour's CPD point a little early today. We'll see. So hopefully we've ticked all these boxes on the learning objectives for today. So as you know, every month we hold a prize draw for a lucky winner of our bottle of finest champagne, which I suspect someone picked up from the Tesco's at Liverpool Street this morning. Here's a photo of the previous happy winners. Lovely. That was December. That's an old photo. So to be our next one, all you've got to do is answer 2 questions from today's talk. So if you've paid attention, you might get it right. If you haven't paid attention, you could probably guess, so it might be right. Or you can phone me and ask me, and I might give you the answers if I like it. That's okay as well. I don't mind that. Unfortunately, the prize draw is only available to our in-person attendees. So apologies for those of you logging online, but obviously we can't hand out bottles of champagne in the post. So that's a bit of a way to encourage you to come along next time. So I'm delighted to announce that this month's winner is a good friend of yours and mine, Tony Walker, but he's not in the room today. It's unusual for Tony not to be in the room, but he's not here. So we'll have to find a way to get that to him. So one of us is going to have to walk through the market at some point today, like an old soak with a bottle of champagne in hand. Steve, I think you can do that for us. That'll be fine. If you want to walk through the market yourself with a bottle of champagne, I'd say please do come along in person next month. And the next one is on the 14th of April. The notes are wrong. 14th of April. Please do join us if you can. Thanks everybody for coming along in person. We really do appreciate it, and thank you to all of those joining online. There's one more. Sorry, I mean, there's one more. Sorry. Right. Before we finish, we want to share some exciting news, which obviously I didn't know about, was that we launched yesterday a new product, Emitter, which actually Paul Martin, who gave us a talk earlier, has been heavily involved in. It's a digital emissions tracker for ports and harbours for them to track and calculate their emissions footprint. This is part of our growing portfolio in maritime decarbonisation. And if you'd like to know more about this, then please give us a call, give Paul a call. Our contact details are all available on the website. This is, really a part of how we're helping our clients transition into what needs to be done in terms of emissions. What we've done here with the ports is to obviously, before they can reduce their emissions, they need to work out what their emissions baseline is today. So this really helps them identify what their emissions are and how we can help them reduce it. So if you've got any questions on that, please speak to Paul, and I think we'll probably get Paul back at some point soon to give us to give us all a talk on this. So that is, I think, the last slide. Good. Right. Thank you, everybody. Real pleasure to have you here, and hope to see you again soon. Thank you very much.